In this tutorial we will discuss ruby laser. Let's start with introduction. A ruby laser is a solid-state laser that uses a synthetic ruby crystal as its gain medium. A ruby laser most often consists of a ruby rod that must be pumped with very high energy, usually from a flash tube, to achieve a population inversion. The rod is often placed between two mirrors, forming an optical cavity, which oscillate the light produced by the ruby's fluorescence, causing stimulated emission. Ruby laser is one of the few solid-state laser that produce light in the visible range of the spectrum, lasing at 694.3 nanometers, in a deep red color, with a very narrow line width of 0.53 nanometer. All lasing media emits heat as well as laser light, so it requires cooler. Working principle of ruby laser. When we switch on the circuit, the radio frequency RF operates. As a result, the flash of light is obtained around the ruby rod. This produced flash causes the electrons within ruby rod to move from lower energy band towards higher energy band. The population inversion takes place at high energy band and electron starts back to travel towards the lower energy band. The electron emits the laser light during such movement. Such emitted light travels between the two mirrors where cross-reflection takes place of this light. The stimulated laser light now escapes from partially polished mirror in shape of laser beam. The spring attached with the fully polished mirror is used to adjust the wavelength. The switching control of the RF source is used to switch on and off the flashlight, so that excessive heat should not be generated, due to very high frequency of the movement of the electron. The characteristics of ruby laser are: it is a solid-state laser that uses a synthetic ruby crystal as its gain medium. It is a 3-level laser. It employs optical pumping. The flash tube is used as the energy source or pump source. The flash tube supplies energy to the laser medium. When lower energy state electrons in the laser medium gain sufficient energy from the flash tube, they jump into the higher energy state or excited state. The ruby crystals have high mechanical strength and high thermal conductivity. It works in pulse mode. And it requires cooler, as all lasing media emits heat as well as laser light, etc. The applications of ruby laser are: they are used in toys for children's due to low output laser. It can be used in schools, colleges, and universities for science programs. It can be used as decoration piece and artistic display. The laser metal working systems are used for drilling holes in hard materials. The high power systems are used for frequency doubling into the ultraviolet UV spectrum. And the medical laser systems are used for tattoo removal and cosmetic dermatology. They are used in high power Q-switched system, etc. The advantages of ruby lasers are: the ruby lasers are economical than others lasers. The beam diameter of the ruby laser is comparatively less than carbon dioxide CO2 gas lasers. The output power of ruby laser is not as less as in helium neon gas lasers. Since the ruby is in solid form, therefore there is no chance of wasting material of active medium. The high brightness holographic camera system with long coherent length is also one advantage of ruby laser. The construction and function of ruby laser is self-explanatory, etc. The disadvantages of ruby lasers are: the ruby laser requires high power pumping source. The efficiency of ruby laser is comparatively low. In ruby lasers there is no significant stimulated emission occurs, until at least half of the ground state electrons have been excited to the metastable state. The defects due to crystalline imperfection are also found in ruby laser. And the optical cavity of ruby laser is short as compared to other lasers, etc. This much for today. Thanks for watching. Bye bye, see you.